Hey guys, in today's video we'll be looking at problem 102, binary tree level order traversal. So as per usual, the 3 steps to solving a problem are 1. Understand, 2. Visualize, and 3. Implement. Given the root of a binary tree, return the level order traversal of its nodes values, i.e. from left to right, level by level. So looking at this, first example, we have 3, you see the 3 down here, then 920 in its own array, and then 1517 in its own array. Then we have some simpler examples here, and our constraints. So we have up to 2,000 nodes, and the value of each node is between -1 and and positive 1,000. So whenever you see level order traversal, like just immediately think the word breadth first search. So as opposed to a depth first search, which is a very unbalanced approach to solving to traversing a tree. Like it kind of like moves like sideways, kind of like this and that. Like breadth first search like does in fact do level by level, and the key element of breadth first search is a queue, where you start off with the root node, you put that in a queue, and then you just keep iterating through the queue where you put its children in the queue and then their children in the queue. And so just imagine, and let me just grab this guy, and let me make it a nice balanced tree here. Just add some random numbers. So we start off with a queue. So what is a queue? A queue is a form of array where it's first in, first out, meaning if you're the first person to the register, you should be the first to talk to the register, as opposed to a stack. But anyways, you put the root node into the queue, then you go through its children and you put those guys in the queue. And when those guys then put their own children in the queue, it's all happening, level by level. So you definitely want that. But then the second element to be able to solve this specific problem, where you put the levels into these arrays, is iteration, where you need to have an iterator. So once you have stuff in the queue, you want to then iterate over the elements in the queue. So at first it'll be just 3, like this number 3, and there's nothing to iterate on. But what its children are in the queue, 9 and 20, you want to iterate over those guys to then put them into their own array. And then guess what? At the next level, you want to iterate over those guys and put them into an array. So that's really all there is to it. So let's visualize this with code now. And to start off, let's just say there's no, if there's no root, we see down here in example 3, we just want an empty array. So it's a very simple situation. So let's create our queue. Our queue is our first array with just our root. And now in typical breadth first search fashion, as long as there's something in the queue, let's do something. And at this point, we have to set up our iterator. So the guy that will be putting the elements in our queue, the guy that will be iterating over the elements in the queue and putting them into, creating a little sub array, and then we'll be putting that array into the final result array. So what does the result array look like? It looks like that. That's the guy that will be returning in the end. And then we need a sort of temporary array that will, then be fed into the result. So, I'll call this temp. And, down the line, we'll be pushing temp into the result array. So, and now let's set up our iterator. So because we are going to be manipulating the queue, and there's often the case with tree traversals that you're manipulating the tree. So you do want to just make it static in this situation. So when you're doing the iteration, you're not accidentally so I want to say for let I equals 0, I is less than length. You don't want to say I is less than q dot length, in case the queue length actually changes in the middle of iterating. And I plus plus. So at this point, so we have that. Now at this point, we can do a very regular breadth first search, where let's get our element from the queue. Let's put it into the temp. and this will be the value because we just want the numbers. We don't want the whole like the whole node. And now all we have to do is, you know, exactly like breadth first search, we just need to put the children into the queue. And you know that's all there is to it. So once again we have, well, let's see if this worked. Okay, that one worked. And okay, so our solution worked there. And so just to reiterate, we just have a queue exactly like in breadth first search, and then the added element to this problem is to have the iterator, where we're iterating over the elements of the queue, putting them into this temp array. At the end of doing this process of running through the iterator, we just push our temp to our result array, and then finally just return our result. So there you have it, calculator.